Okay, in this section we're looking at 45, 45, 90 triangles. In other words, we have two angles in the triangle that are 45 degrees. So this is also 45 degrees. And we also have a right angle here. Remember, if these two angles are congruent, that means that these two sides are also congruent. And hopefully you learned that if we have a triangle like this where these two sides are equal, the basic strategy is if these are both x, then this is going to be x rad 2, and I'll show you why that's true. Basically, if we know these two sides are equal, we could call this c right here, and we could say c squared is equal to x squared plus x squared, where we're going to solve for c in terms of x. So therefore we have c squared is equal to 2x squared, and if we take the square root of both sides, c is over here, x squared comes out as x, and we're left with rad 2 at the end. So basically all you need to do, now that you understand why it is the way it is, all you need to do is remember that these two sides are x when it's 45, 45, 90, and the hypotenuse is x rad 2. So therefore, since this is 8, this is also 8, and this is 8 rad 2. No work needed. Okay. If they give us that one angle is 45, remember that if this is 90 and this is 45, these two have to add up to 90, so this would have to be 45 as well. Okay. So again, we're using the triangle sum theorem to state that this angle right here is 45, so it's a 45, 45, 90, and theorem 7.8, which tells us the two legs are equal, and the hypotenuse is rad 2 times the leg. So they kind of make it look a little bit more complicated, but we get 8 rad 2 there. Here's another one. Same type of thing. Remember, these two sides are equal, therefore these two angles have to be 45 degrees. Okay? So it's a 45, 45, 90 triangle. And sorry about that. Let me see if I can fix that. So therefore, remember, if this is x and this is x, then this is the x rad 2 side. So the third side would be 3 rad 2 times rad 2. So 3 rad 2 times rad 2. Rad 2 times rad 2 is 2. So we get 3 times 2, which is 6. And that's all you do. You just plug in whatever the legs are, we multiply that times rad 2. Sorry about the confusion there on that. It's a 45, 45, 90 triangle. Again, we just plug in the 3 rad 2 here, and when we multiply it out, we get 3 times 2, or 6. Here's another one. This time we're given that the hypotenuse is 5 rad 2. So remember again, this is x, this is x, this is x rad 2. So if you look carefully, that tells us that x is equal to 5. So we could just say x equals 5 at this point. Okay? So again, this time the hypotenuse is given to us, and they again make it a little bit more complicated. We put 5 rad 2 over here for hypotenuse, and then we divide both sides by rad 2. If we do that, rad 2, rad 2, those cancel and those cancel, and there's where we get our x equals 5. Okay? Alright, here's another one. Lots of examples here. We know, sorry again, having trouble with my pad. We know this side is 25 and this is 45 degrees, so automatically that's 45 as well. This is 25 centimeters, and so the hypotenuse, since this is our x, and this is our x rad 2, this has to be 25 rad 2. Our answer is B. Okay. Now there's one more type of problem I haven't shown you, and I believe that's what I'm going to show you next. Okay. Nope, this is still same types of problems. I'm going to go over why that's 2. Again, this is the x rad 2 side, so that means that x equals 2 here, so both of those should be 2. Or what you could do is you could say that the hypotenuse, which is 2 rad 2, is equal to this value, rad 2, and if we divide both sides by rad 2, we end up with x equals 2. Okay. Last type of problem I wanted. Oh, okay, we'll keep going. Let's take a look at this one. Here we have rad 2 here, and this is y. So this, remember, it's x here, and x rad 2 here. So we take this value times rad 2, so it would be rad 2 times rad 2, and rad 2 times rad 2 gives me 2. And here's one last one for this page. We've got 8 here and 8 here, and if you notice, it makes a square, because if this is 45 degrees and this is 45 degrees, then altogether that would be 90 degrees there. So this would also be 90 degrees, so it's a square. So when we have a square and the two sides here are congruent, this side right here, hopefully you can see, is just 8 rad 2, because if this is the x and this is the x, then this side's the x rad 2 side. Okay? And then for the last one, this is the one that I wanted to show you. I'm going to go ahead and draw a 45, 45, 90. Hopefully it comes out okay. No, of course not. Let's try again. Just do it like this. Go this way, and this way, and assume these two legs are congruent. Assume this is congruent to this, which makes this 45 degrees, and this also 45 degrees, and this is 6. Now, this is my x rad 2 side, and these are my x's, so I want to know what the leg lengths are. This time we know that x rad 2 is equal to 6, and this is different from what we've done before. In the past, this would have been something like 6 rad 2, and then we would have had x equals 6. So what we need to do here is divide both sides by rad 2. If we do that, we have x is equal to 6 over rad 2. But when we write numbers with radicals, we can't have radicals in the denominator. So we do something called rationalizing the denominator. And what you do in this case is you multiply the top and bottom by what the radical is. And the reason we do that is to get rid of the radical in the denominator. If you notice, the top now is 6 rad 2, and then the bottom, it gets rid of the radical because we have rad 2 times rad 2. This gives me 2. And finally, we can simplify because there's a 6 and a 2 here. We can't do anything with this here, but we can divide these two. This becomes 1. This becomes 3. So it's 3 rad 2 over 1, or 3 rad 2 is our answer. We can look at more of those if you have more questions about that, but that's it. Okay? Again, 3 rad 2 there. And we're done. Thanks.